Now let's write one last procedure for these trees, contains. We want to see if a given tree contains an element. And the real trick with contains is that I don't have to look at the whole tree. If I'm given a very small element, I'll just go down the left path, because I know it's not in the right path. Similarly, if I'm given a really huge element, I'll only go down the right path, because I know it's not on the left. This is a recursive procedure, so it has a base case. If we're at the bottom of the tree and we haven't found it, then we return false. And now, if this element is exactly the element we want, we found it. And then based on the dictionary ordering, we'll either call ourselves recursively on the left child only or on the right child only. Let's see if our third tree contains midpoint. It should. That's right at the top. Oh, silly Python error. Else if is invalid syntax. Yep, they're exactly right and I'm wrong. I always get this wrong in Python. In Python, else if is written elif. Now let's try again. True, it does contain midpoint. Excellent. Let's see if it contains should not be there. Hint, the expected answer is false. And look, it is false. Unfortunately, there's actually a bug in our code. Let's see if we can find Jacob Zuma. He should totally be there, but he's not. We still get false. Well, if there's a bug in our code, we have to find a test case that shows it. This is a test case that shows it. We tried a simpler one just looking for midpoint, and that worked, so we'll just stick with this one for now. Our next step is to add print statement debugging until we've localized the fault. So here at the top of contains, I'm just printing out the current tree and the element we're looking for. And let's go see what happens when we look for Jacob Zuma. First, the tree is the entire huge tree with Atwood Margaret, the midpoint, and then Zuma Jacob. And the element we're looking for is Zuma Jacob. So that's looking good so far. Then we call ourselves recursively, and suddenly we're looking at the left child. Now we're looking inside the Margaret Atwood tree for Zuma Jacob. That is not going to work. What this tells me is that we went left when we should have gone right. So somewhere up here, there was some mistake involving one of these recursive calls. We went left, but we should have gone right. Well, what's controlling this decision? It's the comparison between this element and element. Here's another quiz for you. Fill in this blank with code that will make this work.